Okay, I guess we should start now. Okay, so, oopsies. Is everything all right? Okay, I hope so. Okay, so virtual threads. Virtual threads are one of the things in Java 21 that brought you to this room, or that made the whole like community super excited, and also industry. And people usually show it like this, right? So, for example, I want to have I will have some tasks, and the task will take, for example, 5 seconds. This is the duration of my task, right? And then let's say I have 1,000 of such tasks to process, so I will start 1 thread per each, right? Makes sense. So I'm creating the thread, and then I'll be showing basically making this whole thing run. So make this whole thing run. Let's see how it works. It started. It's doing or working for 5 seconds, and it ended, and it took us more or less like 5 seconds, right? This is how it took. This is not how you do benchmarks, by the way. This is like how we do silly demos for conference talks, okay? Then, let's say your startup is very successful, and you will have more tasks to do. So what you can do then, you can go for more threads. How many tasks perhaps do we need to have? Let's say 10,000, okay? So we go for a 10,000, and oopsie daisies, it doesn't work. Why it doesn't work? It's exactly, it's written. Normally I would give you jellies if my luggage wasn't hijacked, okay? So I'm passing you like virtual jellies, okay? Exactly. We exhausted the resource limit, right, of regular threads. So here's the big selling point. This is how everyone tells it. When you're creating your thread in this extremely naive way, instead of going like good or platform thread, just go for the virtual one. And then can you run 10,000 virtual threads on this very MacBook I have? Let's try to see. In 5, 4, 3, 2, 1. Yes. And as you can see, they work really fast. In fact, you can go for many more virtual threads. You can go, for example, for like 1 million. And will that work? We just created 1 million virtual threads in 5, 4, 3, 2, 1. It took us slightly more because we had to create those threads. We had to print it. We had to switch between them and whatnot. But still, as you can see, it's doable. The thing is, all these demos are flawed, sort of. And I used to also show it like this way, because, see, the hint is here, I say emulate work. It's not a real work. I'm emulating that I'm working, right? So we have to go for the actual task, where the task is, let's say, see, I have this blocking operation. I think it's not blocking. It's sneaky sleep, and it's just using good old sleep. So I'm cheating. Whatever you have thread sleep in your production code, it's about smell. If you have thread sleep in your testing code, probably it's also like a bad code smell, okay? You shouldn't be using thread sleep in general, except for demos. That's what I'm doing here. So let's say I'm switching to doing some real hard work, right? Which is like a CPU bound, and so on and so on. And for this, let's see how these threads are going to work, right? Let me uncomment this, and then we'll see how these virtual threads actually perform, how they run. So as you can see, I started again 1 million virtual threads. It's just after 5, 4, 3, 1, I finished a bunch of them, and the rest, like the next batch is working and the next batch is working, right? So this is what you need to understand in the first place if you want to start working with virtual threads. Or you can try to understand this to basically butcher them. Because in your professional life, who's been doing Java for like more than 10 years? Very nice. So you've been at least through 2 migrations. First, in Java 5, we had to migrate to this pesky generics. Then in Java 8, we had to migrate to Stream API and Lambdas, right? Another migration. I mean, come on. How many migrations can you have in a professional life, right? So you decide that you go for job safety, and instead of migrating to virtual threads, because you've migrated to this reactive stack already, you decide to show everyone how miserable these virtual threads are, right? So you came here for this room, to get some inspiration, how to butcher them, and this is one of the ways, right? Just use them for CPU-intensive tasks and show that they're actually okay. Very nice. Welcome to this talk. we'll be butchering virtual threads and everything around it like pros today in this very short session, which got butchered because it's only 45 minutes. I mean, come on, it should be at least 1 hour, but okay, I'm not complaining. Briefly about myself, I'm Piotr PRZYBYL. You can find me on social media. I work as a developer advocate for Elastic. I'm also Java champion, Testcontainers Champion, and whatnot. Whenever I have time, I write something, so when you have time, you can go to my personal blog page, softwaregarden.dev. Unfortunately, I don't really speak French, and if you're interested in my name, how do I minimize it? Because there is this lovely company. Their name starts with L and ends it Lufthansa. Right, so basically, I have invalid family name. It is, right? It could have been way worse. Right, so I know who you are because we've introduced to each other, right? Many Java 21 people in the room already. A little warning, everyone can make a mistake, especially myself, and some of the features I'm showing today are in preview, so they can change, right, in next Java versions. So these are the preview features, and who's using Java preview features in production? Okay. If you manage the production, it's not that bad, perhaps. Who's familiar with preview features in general? Okay, not that many people. Basically, you have to go for this --enable -preview switch, and then if you want to know how they work under the hood, what to switch with the compilers and so on, you can watch this part of my presentation from Devoxx Belgium. So let's go back to the concurrency, will you? So as we know, OS threads can be slow to create. How it used to work back in the day, when we wanted our system to do two things at the same time, or many things at the same time, we used to fork the processes, right? Good old Unix days. It's just then we discovered that the forked processes are heavy, right? They take resources, they're slow, it takes time, sharing memories is like a turbo headache, so we went for operating system threads or platform threads. And they were much nicer, we could access the same memory, no big deal. And for a moment we had this thread per request approach. But then our systems went bigger, and suddenly when we have 10,000 concurrent requests, and this is your server, you can't have this approach, right, anymore. So reactive was born. There are many reasons behind reactive. So reactive is like no side effects. It's about blocking or handling back pressure. It's about also like this handling things in async way. The thing is, who can debug reactive stack? Don't be shy. Okay, because I can't, so you're the only one. I just wanted to encourage you. Honestly, I can't do that without like help of the IDE or something. It's kind of difficult, right? And also in Java, we don't have something that our JavaScript friends have, like async await. So here they come, virtual threads, part of the project Loom. So they are part of Java 21 now. And people are asking question, is this the biggest change, since the Lambda was introduced in Java 8, right? And basically, there are two groups of people. Some people say, yes, this is the biggest change since Java 8. And some other people say, excuse me, they say, no, it's even bigger. So this is the change, the size of the change we're facing, right? So virtual threads came as this chap in Java 21, structured concurrency, it was still a preview feature Java 22, and so were scope values. They were both like incubated for several versions before. And virtual threads had only two preview versions of Java, like Java 19 and 20, but their work lasted for years, right? They had different names in the past and so on. So today, the name is Virtual Threads. And they are the cornerstone of the whole project Loom. I would say the whole idea is not to reinvent the wheel, but keep threads concept around. I mean, who knows thread API, more or less? Exactly, right? So we've been teaching Java for like what, over 25 years, right? So everyone has heard, I mean, if you applied for a job as a Java developer, chances are you know like something about threads, else you wouldn't have this job, I guess. They also should be cheap to start because of the lower memory overhead. They also live in like user space. Under the hood, they carried by the platform or operating system threads. And they are mounting these carrier threads when they are waiting, for example, for thread.io or when there are issues with, or thread sleep. Hence the previous demo with 1 million virtual threads worked, right? That was the trick. They're always daemons with normal priority, and basically I would say they work kind of like a taxi. If you have your own car, or a car is like a good all platform thread, okay? And as we know, especially, I mean, Paris is like a great place to describe it, right? The city is not made out of rubber. We can't put as many cars as everyone would wish. Therefore, we have to limit this physical resource, right? And the thing is, if you turn like cars into taxis or Uber or car sharing or carpooling, whatever, then by having the same number of physical resources, right, we can have more people traveling using these cars, using these hardware resources, to put it that way, right? So let's say that the carrier platform thread is like a taxi, and you are a virtual thread when you want to go from here to the lovely dinner, right? Then you are a virtual thread. You mount the taxi, you get into the taxi, and at the destination you get out of the taxi, you unmount it. This is how it works, right? More or less. And then the taxi or Uber can take another passenger, right? And therefore, like having the same number of cars, we can like have more people traveling because the cars aren't like blocking parking lots and whatnot, which aren't easy here in Paris, I was told. Please remember that because of reasons, there is no magic switch that would turn all your threads, all the threads you have, into virtual threads. You have to basically go to your source code and change it, right? Every place, every time you want to use virtual thread instead of good old platform thread, if you have existing code base, you have to change it manually. There is no -XX or whatever flag. So you can create a virtual thread like this. We have like a nice builder now with like runnables, and you can also put like a name, whatever. And this is when you start it when you're ready. If you just want to start a Lambda and you don't care about anything else, you go for start with virtual thread. When you have executors, or you need executors, there is this new executor, and let me see if it works. Yes, it does. And it says, as you can see, a new virtual thread per task. That's important, we'll get to that. And if you need a factory, this is how we get the factory, right? If you are using a framework like Quarkus, Spring, and other ones, then, for example, you could use annotation in Quarkus, or in Spring Boot, you can also put a property or something, right? And then the framework is clever enough to know where to use it and where not to use it, because virtual threads aren't good in all circumstances. Now, it's going to be a long day. It's going to be long 3 days. This is a great conference, right? So if I may ask humbly you to remember just one thing from this conference, it would be this. From this talk, not conference, this talk. Sorry. Virtual threads won't magically squeeze more juice out of your CPU. If you have like intense CPU-bound operation, like we just saw, right? My application doesn't get like more speed, more performance. What it works, it will scale better because of the taxis, right? So it's just like a taxi. If the taxi driver is obeying all the traffic regulations, they won't get you faster from point A to point B, right? Because there's, for example, a limit like 50 or 30 kilometers per hour, right? As if you were driving with your own car, okay? The speed of the journey will be the same. It's just you can have more people using the same car, right, throughout the day and night. Therefore, your application will scale better. That's the difference. Okay, what not to do with virtual threads? I mean, this is why we actually here in this room, right? So we don't reuse them. Whenever you need a new virtual thread, you just create a new one because they are so cheap, so lightweight to create, right? That's why the name of this executor was new virtual thread per task. New task, new virtual thread. Easy as that. We don't pull them because pulling means like reusing, which also makes it important when you want to use like pulling to control flow or handle back pressure or whatever like business term you have in your stack, right? So you have to use some other means like, I don't know, blocking queue or whatever. What you also shouldn't be doing is like you shouldn't be pinning virtual threads. And what does it mean that you're pinning virtual threads? Basically, it's the situation like in these American gangster movies, like Class B movies, right? When you want to go and rob a bank, right? And there's a driver. Imagine you had a driver, you went to rob a bank. I mean, usually it's the other way around. And then you tell the driver, keep the engine running. okay? So normally, virtual thread will unmount, and the driver will accept another passenger as a virtual thread. But when you pin it, when you pair the carrier thread, and you say, stay here and keep the engine running, basically you're preventing other virtual threads from using this carrier thread. And this can happen in two situations right now, as far as I can tell. First, you use I/O for more than 20 milliseconds, or there's like maybe other limit in a synchronized block or method, or you use a native call, right? And how to detect these, that you're misusing virtual threads, like you're pinning them. For example, you have a lovely application. It was written in Java 6, and then it's maintained for all these years, right? And people decided, surprise, surprise, not to go for Kotlin for whatever reason. Anyway, then you can basically test it. You can go like this. You can use this flag, JDK trace pin threads for like full or short. Full has the nice advantage, it gives you the whole stack trace when you're pinning it, right? Or you can listen for JFR events. So I will do this. I have like a tiny little demo, and it's like this search client. So I need to search for things, right? And so I have this searcher microservice, and I want this searcher to start using virtual threads. And what's the best technology when you need to search for things? Naturellement. So in Elasticsearch, we're going to have books index, and we'll be searching for books. It's going to be extremely dummy, simply simplified. And now, if you do this little trip, this little journey from here to here, and especially if you're doing this locally, or even if you're CI, chances are this is so quick, this way and back, that the thread won't be pinned or reported as pinned. So you have to artificially introduce what we enjoy in IT, chaos. Right? So we introduce delay, yes, using toxic proxy, more or less half a second, right? And then setting this up on your machine can be quite difficult. Therefore, to set this whole environment, I'm going to use test containers. So there's going to be 3 test containers, right? One running Elasticsearch, one running toxic proxy, as you can see, this chaos monkey, and we'll put our application in yet another container. And this application will be talking to Elasticsearch, not directly, but with this delayed round trip, right? So this way, if we're pinning any virtual threads, we should be able to detect this. So let me go for the demo, and the demo is yes, should be this, and oh, the test was passing. Maybe you should skip it or not. You see, it was disabled. I mean, all these. Probably it was like a fix like this way, right? Someone just disabled it, and voila. It's working on my machine or not. What do I need to do is like I need to create this application to put it into this container. So this is what I'm doing here. It's not like a proper integration test. It's just I'll be testing the whole thing, right? So I have this artifact because what I have in my test is this. Let me zoom in a little bit. I'm creating a network, right? And I'll be putting this artifact into this container. So I'm creating this artifact to put it here, and I also need to start here and here. And for Elasticsearch, I have some data prepared to just put some data before the test to prime it with test, right? So this is this bulk njson. Which is like a nice format if you need to have like a one bulk request, because with test containers or in general like in testing, you want to avoid this like a single request, like you want to set the whole data at once. Cool. So as you can see, I'm starting Elasticsearch. Here I'm copying this file. Just for the sake of proxying, I disabled SSL. Normally you shouldn't be doing this. Even for testing, I recommend you stay with SSL. Then I start toxic proxy here as well, and I start my container running my artifact, because it was copied here to TMP test jar. I start all of them concurrently. This is how I can easily prime Elasticsearch with data if I have the file already in the container, right? So I copied the file, I have this bulk data file, right? I copy it here to TMP bulk in JSON, and then I can just call it locally using curl. It seems complicated, and it's kind of like is, but on the other hand, it's super efficient if you need to restart the container, because you copy the file just once, right? And then you can just like I have one test. If I had many, I could just retrigger this curl, so it's not sending the whole data over the wire over and over again. The data is already in the container, right, for all the tests. Yes, so then I create this proxy. See, I'm setting that it's going to be like half a second, more or less. And then inside the container, I'm going to execute the thing. I'm telling my thing that it should connect to this via this proxy, right? So it should go this way to search for stuff in Elasticsearch, right? And this is what I do it. This is what I run. So let's run this. Let's see if it works. Let's debug it. The containers are starting, as you can see. So Toxi proxy already started. JDK started. Well, Elasticsearch already started as well. Okay, it's not shaking here, it's shaking over there. And now let's pray to demo goats that things are working correctly. Yes, so we stopped here. And see, this is the beauty of test containers, that you can go like in these gangster movies, you went into the bank and you shouted out, everybody freeze. So we froze the thing, right? And now we can inspect. See, I have the result of this call of this application, and I can see, and this is what I see because I use this flag. See, I use this flag here, this trace pin threads. Therefore, it's giving me full stack trace when the pinning is happening, if it's happening. Basically, it says, you are pinning virtual threads, you idiot. Okay? Sorry, I'm Eastern European, so we are pretty direct. Yes, and it tells you so, and then it can even show you here monitors when it happens. See, in book searcher in line 24. So let's go to book searcher line 24. Come on, book searcher line, sorry, that was 54, right? Yeah, see, and it's because I am doing this I.O., like I call REST high level client, I use search, right? And I do it inside synchronized method, right? So it's just perhaps like a leftover, let me remove it, let me go and like rebuild the thing again because I need to create this like a new artifact to be deployed for the next subsequent test. I mean, if it was like a CI build, this would have happened automatically, right? And now let me run the test again. And yes, one container started, second is started. I could have used the like a reuse for Elasticsearch, but that's like another talk, another topic. And let's see now if it has this on pinned now, right? So let's see, this assertion passed, which means we are not misusing, we're not pinning virtual thread when doing I.O., right? Even if the I.O. takes like more or less half a second. But I'm afraid, so this test should pass. That's one thing, but the other thing is, like, you see, this client is kind of like deprecated, if I'm not mistaken. Also because like it's not like it's not modern, and you don't see this because I like disable it, right? So what you actually should be doing instead of going for this using this old client, maybe you should switch to new client. When you try to work with Elasticsearch, right? So this is what I should be doing it. See, I have, does it work? Yes, it should be working like this. See, I just create, I will use another method, which in fact is using this Elasticsearch client, right? And the beauty, see, I'm using it in a blocking way. I'm not doing async search. I'm using just search. So, oopsies, let me go for the terminal again. And now let's rebuild it again. Very nice. And okay, done. And let's rerun the test with this new client. And we'll see if the test is passing or not. So basically, these two methods are equivalent. They're doing the same, right? It's just instead of old client, I'm using the new one. Right, and the test, come on, these integration tests can be slow, but it passed, despite synchronized here, right? So you're using a client, and it's a blocking call, and it's used inside synchronized, and it's still not pinning. How come? Because this is a great job done by client team at Elastic, right? And this thing is using its own thread pool under the hood. Right? So as you can see, it's already ready for this. If you need to know more about this, like how to switch between those clients, you can talk to David. He made like a very nice blog post about this. You should also contact David for Elastic stickers because mine got hijacked at the airport. Sorry. All right, so let's keep going. If you prefer reading, I described this whole procedure on my blog, right? So even if you have legacy system, you just put it into container with this flag, and then you just check the output if it doesn't say anything about pinning virtual threads. Just make sure you have this chaos monkey in place, so you have these calls like extended, right? To whatever other dependencies you have. This could be like any other database, like whatever. All right, how many lights are here? 4 or 5 lights in this room. Right, it's just things may look differently when we look at them, right? So let me go for another quick demo, right, and that should be this thing. Yes, so what I'm doing here, basically, quick question. I have this stream task, okay? Maybe I can minimize this. Yes, I have this stream task because I have a task to do, and what I'm doing here is I want to do this task, like handle this task 100 times, and I'm using like a parallel stream, okay? And each task takes 5 seconds. So if the whole program runs for 6 seconds, how many tasks will I complete? I had 1. Who can give me more? Who can give me 10? Who can give me 20? Right? It all depends, actually, with the default config, it all depends on this. I have 12 cores in this machine. Okay? So what I'm doing here, right, let's try to run this thing. I should have in like 6 seconds, it should tell me how many tasks I started and how many tasks I finished. So I finished 12 and I started 24. So I was doing 12 tasks for 5 seconds. They were completed, so another batch of 12 was taken. Yeah. So then your boss comes, and because like KPIs and whatnot, and they want more, right? So what do you do to double the performance, right? You try to double it like this. Oh, come on. You go like this, and so you have like another parallel stream. Question, how many tasks will we complete in 6 seconds again? 0, same. Any other answers? It depends. Very good answer. The brilliant answer is it depends because like, and let me go here and let's try to run it. So we see, as you can see, we started 2 streams and now I have 13 completed. Why 13? Because my fork join pool is of size 12, right? Or size like it depends on the size, sorry, of the CPU by default. I mean, I could tune it, I could change it, but that's just the default. And we have this extra thread and this extra thread. So this extra thread added 1 more, hence 13, not 12. Okay, but apparently this is not the way, right? So what's the way? The way must be obviously going for virtual threads, because they make things so nice and so fast, right? So instead of going for stream task, we're going to go for virtually threaded tasks, which means we're gonna start again these virtual tasks like this. So how many tasks will I complete in 6 seconds? And boom, 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 boom. It's 12 again, because the company, the taxi company, is called fork join pool. Okay, it's just spoiler alert. It's a different pool than the one used for streams. Okay, but the same, like under the hood, you can't just use any carrier thread you want. You just need to. I mean, the company will be provided by JVM for you, right? So, but you say ridiculous. Maybe we can like debug, like why is it so slow, and see. So I'm going here to this handle task, right? And instead of working hard for 5 seconds, what I will do, I will report every second the progress, right? So I will do like. Report where I am, work for 1 second, work for 1 second, then report where I am, and so on. So for this, I need to, when I go for this report, you see it's a logger fine, so I need to enable fine logger in where is it? Keep scrolling, Piotr. Okay, it's here. So now the question is, how many tasks will I complete? And here's the answer: it depends, or it varies. Because, what the heck, we wanted more and it's just 5. This is how you butcher virtual threads, mon amis. Really, mes amis, sorry. My French is really rusty. Depends how you measure KPIs in your company, okay? Finished, only 5, but look, we started them all, right? And the thing is, we don't even see the output, so what the heck? Right? We wanted monitoring, we wanted more performance, instead we have the same monitoring and even less performance, right? Brilliant piece of engineering, how lovely. The thing is, did I tell you when the virtual thread is changed in the cab? When you unmount it, right? When you go for a lovely lunch or whatever, right? So then, I mean, I don't know how actually taxi companies are doing this, but it works more or less like this. When you were taken here by a taxi and you want to go back home, when you call them in the evening, are you guaranteed any higher privilege than the other people who want to rent a car? Exactly. So once you unmount as a virtual thread, you're equal with everybody else. All right? 1, 2, 1, 2. Okay, it's still working, sort of, I hope. Very nice. Exactly. I mean, maybe there are special algorithms at Uber or taxi companies, I don't know. But this is what happens, right? When you get out of the taxi, I mean, you have equal chances getting into the taxi as everybody else. And because we have such a high pressure here, we just created 100 tasks, we don't know who will get there. And just by introducing this, introducing this reporting, we have I/O, because logging is I/O, right? So it unmounts, basically. So maybe we should monitor without I/O. So how can we monitor without I/O? It's not the perfect way, just to give you a hint how it could work. So for example, I could have, where is it? Come on, I could have this tree map. I'll be collecting like where I am, right? And now let's go and print whatever I have here. And also in this report, where's this report? Come on, scroll. Where's this report? Come on, here. Yes, I will put this into this map. Let's see what happens now. In 5, 4, 3. See, and this is like. Now we have some in 5, some in 2, some in 1, because I disabled the logger. So it kind of like tells you what you basically were expecting, right? So first batch was completed and the next batch was taken. But if we enable this done logger, which means we introduce the I/O, what happens is in 5, 4, 3, actually how much time do we have left? Okay, see? This is what happens. Some of them are in 2, some of them are in 1, and so on and so on. So it gets like basically, when you want to observe the system, right, it just making the observation in a bad way impacts how the system behaves. Okay, so be mindful when monitoring the tasks handled by virtual threads. That's one lesson, and the other lesson is handle back pressure correctly, okay? Because now we see we didn't wait for the tasks to complete before we started new tasks, okay? We just started them all, and then they created, it's like the concert ends, right? And there's like a few thousand people or a football match, right? And everyone wants to get a taxi. You know what happens? This is the situation, okay. So structured concurrency is another thing. It's about having better idioms for multi-threaded code and should help us eliminate thread leaks and cancellation delays. And for now, it's not replacing interruption with cancellation. And it looks like this. Question, have you heard this story that obviously didn't happen to you, but one of your friends, that they came to the office in the morning and they saw a ticket in Jira or other ticket system that, for example, a bank client was shown in the bank page statements of a different client. Exactly. Like you don't have to vote, just blink, because I know it's embarrassing, right? Chances are this happened because of thread local, right? So, for example, the thread exited in a unpredicted way, and nobody cleaned the client ID in thread local. So when the next client was given this thread because of like thread pooling, right? Then the second client saw the statement of the first client, right? Nasty bugs. So we should have structured concurrency. Sorry, I messed the examples. It would for the second one. Okay, let's go with the second one. Yes, it's this one. So these are the thread locals. See, I'm a little bit stressed here. What the heck has happened? Now it's like something with the keyboard. It's just, Mark, you're not helping here. Let's try this. Yes, okay. So we should have now scope values which act as one-way immutable thread locals, and they should have bounded lifetime. And this lifetime should be visible in code, right? And therefore, we should have simplified reasoning, so no like head scratching, where did we forget to clean this thread local, right? And it should all improve performance, because if you have 1 million virtual threads, and all of these threads want to have their own copy of something in thread local, you're gonna have 1 million copies, or at least 1 million references, memory, right? So it's better to have just one thing. So the thread local doesn't change with this and doesn't get deprecated. And this is more or less how it looks like. Let me go for the code. The code is usually better, right? So it is, where it is, scope values demo, right? Very nice. So I have this thing. Do we have any Star Wars fans in the room? Very nice, because this demo is Star Trek. Yes. So this looks like, these are the warnings, because it's like what? Like a deprecation or whatever. Sorry, it's like a preview API. That's why it's like in this color. So instead of having a thread local, I'm gonna have scoped value, and it's security clearance level. And normally you should get it. I mean, that's the idea from HTTP request. For example, like from a JUIT token, like any other token, whatever, right? And then we have a Starship, which is Voyager, which was like taken by aliens across the galaxy 70,000 years ago, away. And then see, I have this scope value where, and I just set for this clearance level the level I have from the request, okay? And then I can do some stuff on board of my ship, and then I can nest it like the Matryoshka way, you know, the doll, right? So then inside this scope, I can have yet another deeper scope, like Leo DiCaprio. We have to go deeper. And we set level for prisoners, which is 0, okay? And then we do some stuff on this Voyager again, and see, here we end this run, and with scope values, it gets cleaned. So this level gets again to this level, not level for prisoners. Okay, and what's the stuff we can do? The stuff we can do is like we can turn the lights on and off. We can locate where Commander Tuvok is, and we can block bridge controls. It's just for lights. We don't need any privileges. Any level will do. For locating crew member, we need to be a member of the crew, so have the level of at least 2. And to block bridge controls, you need to have a level of a captain. Magic values don't do that in production code. It's demo only, okay? And when I run this thing, you see what happens. So I had level 5, right? I could, even if I'm in prison, we're not KGB. We don't torture people with light, okay? Even people in prison can turn the lights off. So they can turn lights on and off. They cannot block bridge controls, but they can locate where Commander Tuvok is, right? Then we put this person to jail, and so level was 0. Basically, they can't do anything beside playing with lights, okay? And then after this thing got cleared here, we are back to the original level, you see? So this is why we don't have these leaks. Yes, very nice thing. Okay. Unless you misuse it, of course. And now let me try to see if I can misuse it. Oops, sorry. How do I work with this keyboard? Let's try to apply this patch. Oh, come on. Did I do something here? Or are there any changes? Let's roll back the whole thing. Yes, like everything. Come on, and let's apply, because I'm short of time. okay, it's still like, accept this, whatever. It's the different demo. Yes. Okay, so now the thing is not integer, but atomic integer. And what's the nasty property of atomic integer? Yeah, it's safe, only it's mutable. That's the point. That's the whole point. So it's so safe that when someone tries to do some stuff on the Voyager, right, and we're turning lights on, somebody, oops, by just accident, sets the level to 50. Okay? It's so darn safe to use mutable things. Yes, so let's rerun this demo. And now you can see here, what can we see? We had level 5. So we had level 5, but suddenly we were able to block bridge controls, right? And then we put this person to prison, but they were still able to block bridge controls or locate commander Tuvok, right? Basically, what I want to tell you is that when you, like, scope values work nicely with structured concurrency, which will be the last demo. You can use them with run or core, and the work can be nested, right? This is how it works. And it works very nice as long as you don't mutate the darn thing. That's why I would say integer, in this regard, may be safer because it doesn't mutate, right? Whereas atomic integer or like this array of size 1 and everything can mutate. That's the point. So it doesn't play well with scope values because it kind of puts you, basically makes you more exposed, right? Okay, let's go to this last demo for today, which is the structured concurrency. Sorry for messing this up. This is how it looks like. Let's go for a demo structured concurrency. Yes, okay. So I have this scoreboard, this big scoreboard, and I need to put player's name score, and I have two services. One which gives me user ID and username, pang, and the other one which gives me user ID and current score, pang. One network core, another network core, I combine the results and display them, okay? So this is the first approach of how I can do this. So I can get names from the name service and score from the name service. This takes 1 second, sorry, 1 second, yes, this takes 1 second, so how long the whole thing is gonna take? 2 seconds. 1, 2. Yes, it took more or less 2 seconds. So Susan has 100 points, as Joe and Krzysztof has 300. Cool. Now, your manager sees this, the Scrum Master, Product Owner, and all the other vists, and they tell you, make it faster. What do? Async. Okay, bravo. Yes, async. So let's try to go async. So we're going to use futures, right? So we create one future here, one future here, right? We wait for both, we combine the results. How long is it gonna take? 1 second, okay. Yes, very nice, 1 second. Okay, cool. Now, let's say we go to this name service, right? And we break it. Something breaks over the network. And of course, it means we won't be given the results, right? As we should be. Only it happens after 1 second. So how long it takes before we know there's a failure? 1 second. Let's see. Let's verify this. We're engineers. We should verify things. Yes. Oopsies and 1 second. Very nice. What happens if it breaks immediately? Okay, 1 second. Sorry, wrong key. Yes, it takes 1 second. See, it says here 1 second, more or less. Don't do benchmark like this. Why? Because we have these two services, right? They are here, and when this guy crashes, it doesn't notify the other guy. There is no point. I mean, the part is over, just go home. Okay? So what we could do, we could subscribe one future to another future. With two futures, kind of like doable. Ugly, but doable. With 3 futures, we have 6. With 4, my math doesn't go that well. That's why it's called callback hell. Okay? So instead of this, maybe we can have use this structured concurrency, which looks like this. We have shutdown on failure, and we fork subtasks, And this is where we split our work to be asynchronous, okay? And here we make like a synchronous checkpoint for waiting until all of these are complete, okay? So how, and of course if it fails we throw an exception. How long will it take this time? 0, exactly. Because when this guy failed, it instantly notified, like canceled this guy, party's over, go home, right? And of course, if I like get rid of the bug or when I fix the DNS, because it's always DNS, and it's always cache, unless it's DNS and cache. Let me run it again. Now, of course, as you can see, it runs and it takes 1 second. So it doesn't give you any advantages, right? Unless, right, yeah. If things are working, it gives you advantages. If it's not working, we're almost out of time, but let me just show you how to butcher this thing. So the whole thing is this sneaky sleep. Let me introduce this bug again, like this. And now, instead of oopsies, sneaky sleep, what's going on? Okay, that's not my bug. Instead of going for this thread sleep, we're gonna go for a real actual work, right? And now how long is it gonna take, even if it breaks immediately? It will take 1 second. Why? Because now it's no longer sneaky sleep. What actually happens is a hard work, and this hard work doesn't want to be interrupted. Okay? So once we make it interruptible, again, let's rerun. Now you see the benefits of the cancellation. So the point is, how do I get here? Here. The point is, we get free cancellation as long as the task inside is cancelable or interruptible, sorry. And there's another, like a shutdown on success, right? If you need to, like, for example, you have 2 caches, one another, whoever answers first, no exception means you have success. Don't forget join until. And remember that the subtask should be interruptible. If they're not interruptible, you have no cancellation. This is how it works. So we've been here because I messed up, sorry. So how can we butcher virtual threads and their friends? Use virtual threads mainly for CPU intense tasks, okay? Virtual threads are good for waiting, are good for I/O. Forget this, use them only for CPU, like heavy computation. Swarm the tasks without any flow control. Ignore unmounting for I/O, like forget that this changes the behavior of the system. Pull them, reuse them, mix them with synchronized, ignore interruptions, and mutate scope values. I mean, if you want job safety, these are all the malpractices you should be doing, okay? That would be it. I would ask you not only after this talk, but after every talk to like provide feedback. So use the app for this, the Devoxx app, right? Just appreciation for the organizers and speakers for every talk, every meetup. If you're watching this on YouTube, do 2 things: hit the subscribe button and please go for this little online survey. I mean, if for whatever reason you prefer this, go for this. If you fancy to follow me for IT insights like Java hints or just pool life advices, this is me on social media. In 3, 2, 1, okay? And this is it. If you want to have the slides, the code and everything, this is the picture you should be taking right now. In 5, 4. No, seriously, people, I'm terribly sorry, like I'm clumsy with this machine. That's why it went over time. Okay. This is it. Butcher virtual threads like a pro, people. Merci. Sorry, I need to take a selfie for my boss, so he's content and everything. What do you say in French? You say fromage, right? So, come on. Now it's like, okay, fromage, everyone. Thank you.